Subtracting with counters. I know that I previously said subtracting didn't exist. However, it is possible to still think of subtracting in our old understanding of the term. So instead of combining a positive and a negative, we can actually still model subtracting. So let's see what that looks like. Let's just look at a typical model. Let's do 5 minus 3. Okay, I know that 5 minus 3, I'm dealing with positive numbers. I have 5, I'm starting with 5 positives. Okay, now I want to take away 3 positives. So I'm going to take away 1, 2, 3 positives. Once I take away 3 positives, I'm left with 2 positives. My answer is going to be positive 2. Okay, so let's look at this type of model now, except for with positive and negative integers. Okay, so remembering that positive is yellow, negative is red. Let's look at what it would be to do positive 5 minus negative 2. What this is saying is I start with 5 positive counters, and I want to take away 2 negative counters. Okay, well, how can I take away 2 negative counters if I don't have any negative counters? And the solution to that is we can add a zero pair. And a zero pair are the numbers that we were canceling out when we were adding or subtracting positive and negative integers. So by adding a zero pair, I'm adding negative 1 and positive 1. So really I'm not changing 5. I still have a total of 5 here because these would cancel each other out. But by adding 2 zero pairs, I now have 2 negative chips. And so with 2 extra negative chips now, I can take these away. So I'm taking away my negative 2 counters. So what's my result? My result is 1, 2, 3, 4, 5, 6, 7 positives. So my answer to 5 minus negative 2 is going to be positive 7. Okay, let's look at another example. Let's look at negative 3 minus 2. Okay, this means I start with 3 negative counters, and I'm taking away 2 positives. Well, I don't have 2 positives to take away, so I can add zero pairs. So here's the 2 zero pairs that I added, right? There's a pair and there's a pair. So now I can take away 2 positives, 1, 2, and I can see that the result is 1, 2, 3, 4, negative 5. Okay, and according to my notes, let's just look at transcribing this and how we can figure out what this result would be without having to add zero pairs every time. So remember that I said there is no such thing as subtraction, that this is really a negative sign that belongs to the 2, and I'm combining negative 3 and negative 2. So this is where those negative 2 come from. That's why I'm really adding these 2, is because I had to add 2 extra positives so that I could take them away. And if I add 2 positives, I also need to combine them with 2 negatives, so that way they are a zero pair. Okay, what would negative 6 minus negative 3 be? Okay, so I'm starting with negative 6, and I'm taking away 3 negative counters. 1, 2, 3. I'm taking 3 negative counters away. Notice I didn't have to add any 0 pairs because I was taking away negative chips and I already had negative chips here to take away. So that's why I don't have to add any 0 pairs. I can just take my negative 3 away and I'm left with 3 negatives on the board. So again, thinking of this not like subtraction, rewriting this as an addition problem, I'm combining negative 6 with the opposite of negative 3. And I know that the opposite of negative 3 is positive 3. Okay, so negative 6 plus positive 3 now. I can model that. I have 6 negatives, and I'm combining them with 3 positives. I'm going to cancel out my 0 pairs, and I'm still left with negative 3. So you can see that we can still model subtraction. Modeling subtraction does still work. However, when we're just doing it on pen and paper, and the way we need to start thinking about it by the end of this chapter is that we're changing the subtraction to an addition problem, and we're adding the opposite of whatever we were subtracting by, because a negative or a subtraction just means the opposite.